A water droplet has mass m and has 10 excess electrons, each of charge E. It is suspended, motionless between oppositely charged parallel plates as shown in the sketch at the right. If the distance between the plates is d, show that the potential difference between the plates required to hold the droplet motionless is given by delta V equals to mg times d over 10e. This is the graph. First, in order to keep the droplet motionless, we have to draw the force diagram first. It is given that the mass of the droplet is m, so the gravity is mg. To keep it motionless, we need an upward force to cancel mg, which is the electric force from the negative charge plate. So that would be Fe. Now let's write this equation out. Mg equals to Fe. Now, we know the electric force is the charge of the droplet, in this case is 10e, times the electric field between these two plates. That equals to m times g. Now, in order to find E, we have to solve another quantity. So now we know that force equals to works equals to force times distance. In this scenario, it would be Q times E, which is the electric force, times D. Now we know that the work done on the droplet equals to the change in potential energy, equals to the charge of the droplet times the change in potential. So Q. So now we can have this equation, which is Q times ED equals to Q times delta V. Cancel out the Q, we get delta V equals to ED. Well, in this case, the D is the capital letter D, so now we can isolate the electric field, and we get delta V over D. Now we have this quantity, we plug it back into that equation, and we will get Q times delta V D equals to mg. Well, in this scenario, Q, the charge on the droplet, is 10e. So 10e delta V over D equals to mg. And by solving for the desired quantity, which is delta V, we will get delta V equals to mg times D over 10e. And that's the quantity they're looking for.